Hey everybody, in this video we are going to have the fastest possible lesson on how to graph sine functions with all transformations. So that includes vertical, stretches, reflections, compressions, horizontal. We're not doing horizontal reflections because, to be honest, the sine of negative theta equals the negative sine of theta, so you would always take that negative from inside and pull it out. You would just end up making it a vertical reflection. Sine is an odd function, so a vertical and a horizontal reflection are the same thing. If you don't know what I'm talking about, just know that you're probably, there's almost no need to focus on the horizontal reflection. Anyhow, horizontal shifting, okay, and vertical shifting, all right? So first and foremost, we need to design, create, derive, figure out the parent function of the sine wave. And if you want to do that, that means you should probably know the unit circle. At the very least, you should know the quadrantal angles on the unit circle. The quadrantal angles are the ones that separate the quadrants. So those are 0, pi over 2, pi, 3 pi over 2, and then finish it off at 2 pi. So I already filled this in. These are going to be our inputs for our graph. The inputs go on the x-axis, or in this case, maybe I call it my theta axis, whatever. Now, you want to pick this amount because this is how long it takes for the sine values to start repeating themselves. So that is what we call one entire period. A period is a portion of a graph, of a pattern, of a design that when you put them side by side, it connects where it picks up where one leaves off, and it does one complete cycle of whatever it is. So those are my inputs. On a separate circle, just to save us from cluttering, I have my output values. What is sine on the unit circle? I'm not giving you a whole unit circle lesson right now. That's for another day, another video. Go find it on your own. The sine on the unit circle is found by the y value of the ordered pair corresponding to each of those angles. Again, I could be more articulate with this, but let's just, it is what it is. So what is the y value? Again, this is on an xy plane. This is over 1 up 0, so the y value is 0. So the y value is 0, the y value is 1, the y value is 0 again, the y value is -1, and then loop around, the y value is 0. The y values. Now in this quadrant, sine is positive, sine is positive, sine is negative, sine is negative. That's something else you should know by this point. Now I'm going to take this information. Oh, the period is normally 2 pi. If you have a b value, here, A, B, H, K, just like all of the other chapters, all the other videos, except polynomials. That was like a special one. Just like everything else, B is inside of that backward house, and it works in the backward kind of way. We're really going to transform. I'm really smart. Let's fix that. Transform. Sorry. Typo. You would divide by the b value instead of multiplying by the b value to get it to do the opposite of what you want. That's why the period formula is in fact 2 pi over b. When b is a fraction, please remember the way you divide by a fraction. Most of you would consider it to be something called keep, change, flip. You do 2 pi times the flip. And always look to reduce before you multiply or divide, like simplify everything you can. We're also going to find what we call Q, which is a quarter period. Quarter period is exactly what you would think it is. It's 1/4 of this multiply the period. Now that that's all out of the way, let's go ahead and graph our parent function of sine. I'm not going to always draw the x and y axes. I'm going to use this little grid to really represent it, but I'm over here right now. So when the input, 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 input. Those are your inputs, okay? That's what we're putting in. That's my x-axis or my theta axis. Based on each of those inputs, my corresponding outputs can be 1, 0, or -1. We just saw that on the other circle. So at 0, it's 0. At pi over 2, at pi, 3 pi over 2, 2 pi. Now this graph is going to be a smooth curve. The concavity will flip right over here at what we call the zeros. Now I'll call them zeros even when I shift it up and down. Zero is another word for x-intercepts, but when the whole thing moves up or down, it's all holding on to that line going across, which we will call our midline for a simpler word, sinusoidal axis if you fancy. So it's going to be concave down and then concave up. Now this graph truly does continue forever in both directions. It never ever stops. On and on, both that way and that way. What we're graphing is one cycle the initial period. And then if you were following along my other videos, this little plus sign, that is my calibrated center. I move it left, right, up, down, just like the other graphs. So that's why my first tick mark corresponds to this. It might move left, it might move right, it might move up, it might move down. Hopefully it connects. So keep thinking about that yellow little guy right there. Symmetry. If I rotate this graph 180 degrees, I will get back the same picture. It's odd. It's like the cubic. It's like the cube root. Yada, yada. This is odd. Now, here, I have all these things written out with K, H, A, Q, whatever. So quickly, concave down, concave up, right? And let me get another marker. So that one I just drew, that is sine theta, where the sine theta is A is positive. If I were to have negative sine theta, vertical reflection, the shape just changes to look like that. So that's what we really need to know when we're graphing sine. Oh, also, do you see like a mirror image in a way? S-I-N theta, like sine theta. So you see the S, and I'm going to make a C turn into cosine for the cosine graph. If that helps you using a mirror image part of your brain, great. The domain is really from negative infinity to infinity for this graph. The range, and that's for both of them. The range, however, for both of these graphs is the first one, it's from -1 to 1. It's oscillating between -1 and 1. But for here, to be more general, it's from K minus, more I should say absolute value of A, comma, K plus absolute value of A with brackets. Can you see? There we go. Okay. Now, just to explain where all of this comes from, our midline or sinusoidal axis is the line that is sort of maintaining that equilibrium between the humps that go up and go down. And that right there, it's not an asymptote, although we do draw it dashed. We don't go up against it. It just is there, kind of like the axis of symmetry if you use those when you graph parabolas when you were in middle school. All right, so that is where K comes from. So the whole graph, if it moves up or down, K, right? If it moves up or down, that axis is what moves. So it's like everything's holding on to that, okay? Like a little monkey bar kind of thing, you know? The A comes from our vertical stretch or compression. So this distance here from the midline to the maximum or the minimum part of the hump, that distance is equal to A. You go up A or down A to get there. So that's why I just was squeezing in a box. So I didn't put the absolute value bars there if it's negative, but you get the gist. You would add the A amount and you subtract the A amount. It gives you your high and low point. So how far up we go, how far down we go. So it was normally 1 and 1. It's a vertical stretch or a compression. It pulls it vertical or it squishes it closer. So that's the A value gets impacted by that. The K value was your midline or sinusoidal axis. The H value is how much we shift left or right. So that little crosshair, right, where it goes, is impacted by H. So that moves us left or right against backward house, okay? And almost there, where am I? Sorry, I'm looking for a good marker to write with. Here, the B value, the period, again, will equal whatever you calculate to be 2 pi over B. And then the quarter period is 1/4 of that period. These are all the same size from here to here, from here to here. It's like they each kind of represent the quadrants, right? And here to here. How big are each of those spaces? I'm glad you asked. They're Q. So once you know what value on the x-axis you start at, you just keep adding Q every step of the way. Most annoying part of the whole process, and it's not even that bad. It's like 4th grade stuff. Most annoying part of the process is you might need a common denominator between H and Q before you start adding them. That is it, my friends. Are you ready? Let's go. So if we're going to do an example, here we go. Example, graph this. And your teacher might be so nice and not even give you anything this intense. Like I literally changed everything on here. everything. The A, the B, the H, and the K. A lot of times you get a lot lighter stuff than that. Oh yeah, that's the keep, change, flip reminder. Okay, so let's buckle up. Let's go. Okay, let me see if I could kind of keep the same color coding consistency. 4 is my K value. So this is 4. This is my dotted line, my sinusoidal axis. If you want to know how to spell that, that says y equals 4. Can you tell? I don't know. See it better? So y equals 4 is my sinusoidal axis, okay? There it is, all the way across. Next, the A value tells me how high and low I go, so that A value is 2. So what's 4 plus 2? 6. And what's 4 minus 2? 2. There we go. So that A value helped me figure out that, because this distance then is 2. It's normally 1, and 2 is a vertical stretch of 2. It's the same transformations we've done on everything else. Vertical stretch of 2. Next, we have, what is my first tick mark? This is probably the most commonly mistaken pieces of the whole thing, and people mess up if it's positive or negative. It's minus, but it's in our backward house. So that means this is really 6 pi over 5 positive. All right. However, I might need a denom. So let's wait and see before I commit to anything. Okay. So 6 pi over 5 is my first tick mark. So where is this little crosshair that I would have highlighted in one of my earlier graphs? Happy you asked. That would be there. Where is 0, 0? Honestly, who cares right now? It's somewhere to the left and down, so it's somewhere over here. I'm not even drawing the X and Y axis right now because it gets so messy. So I'm not going to do that at this time. Now, what do I still have to do? Period and quarter period. So I have a lot of markers filling all over the place. So here, the B is 3 pi over 5, right? So period equals 2 pi over, not 3 pi over 5, 3 over 5. I think I said pi. Keep, change, flip. 2 pi is my keep. It's really over 1 times 5/3. 10 pi over 3. Big suggestion. Don't lose what you're labeling it as. That's P. So Q is 1/4 of 10 pi over 3. I'm not multiplying and making it 10 pi over 12. I'm going to reduce by 2, 5, 2. So Q equals 5 pi over 6. Circle it, love it. That's Q. That's what I need to add to this. Worst part, I told you, worst part of the whole thing. What will be the common denominator? Let me get a good color. Okay. All right. The common denominator is going to be between 5 and 6, so that's 30. Of course, the one I get has like a dull. There we go. So I'm going to multiply this on top and bottom by 5. And this on top and bottom by 6. That gives me a common denominator of 30. So that makes this, for this box, can I even fit it? Like, who thinks that that box is big enough? Not me, and I made it. 36 pi over 30. The Q that I'm adding, right? I'm doing plus Q, but in this one I'll write it with the common denominator, 25 pi over 30. 25 pi over 30. So 36, 46, 56, and 5 more. 61 pi over 30. Again, 61 plus 25, the denominator stays the same, hence finding a common denominator. 61, 71, 81, 5 more, 86 pi over 30. 30. Again, plus 25. 86 goes to 96, 106, 5 more. 111 pi over 30. And then 25 more. 111, 21, 31, 5 more, 36. 136 pi over 30. Only thing I didn't do, draw my stupid graph. Hello. So, positive or negative? Positive sine wave, so beautiful. Done. That's it. Domain and range. Last thing. Okay. Domain is always from negative infinity to infinity. The range is always bracket min, comma max. All right. So what's the min? 2, comma, what's the max? 6. Done. There you go. Now you're a genius and you can graph the sine wave. 16 minutes. That's not bad. That's not bad. That's a lot of information in 16 minutes. I will have other examples. I do have other examples and videos on my graphing playlist, strictly graphing. Look for that. I might have a graphing trig playlist. Look for that. I'm going to do just the fundamentals of how to graph cosine next. Thumbs up if you are like, oh, epiphany, I didn't realize. Oh my God. Thumbs down if you hate everything in the world and you're just a negative cranky pants. Comments, questions, concerns in the comment section. Help somebody by answering their question. I'll answer if I have time. And interact with the video. Thanks. Bye.